Okay, your question was about how to find maybe another way to find the critical points from the example video. So I don't know if this is going to help, but I'll see if I can help. So really what he was doing is just kind of doing a shortcut, but what we're doing, we set these equal to 0 because we're trying to find our critical points. So we set each of our partial derivatives equal to 0. Okay, and this is the I'm using so hopefully this will help when you look at the video. I'm using the partial derivatives that the video had in it. So set each one equal to 0. So that gives me 2y equals 0, x minus 2 equals 0, and y minus 2 equals 0, right? Because if this is 0, then that's going to give me 0, and so on. And the same thing with our second partial derivative. Set each factor equal to 0. So each factor equal to 0. So here if I divide by 2, y equals 0, x equals 2, and y equals 2, x equals 0, x equals 4, so y equals 1. So we're going to look at these and see if we can come up with our critical points. So let's start with this right here, where y is 0. So again, if I put 0 in here, I get 0. So what happens if I put 0 in for my y over here? 0 minus 1 is a negative 1. So what would my x have to be in order for it to be 0? That's what I'm going to pair up. So I know x, if x is 4, that's going to give me 0. But there's more than one, because x could be 0 also. So for that same 0 here, remember this is what gave me 0 over here, is y is 0. If I put 0 in over here, well, x could be 4. That would 4 minus 4 is 0, so that times all of those would be 0. Or x could be 0, so we're looking at 0, 0. So there's really two that go with this y equals 0, 2 points. Okay, let's look at this x equals 2. So again, if I put 2 in here, that gives me 0. So if I put 2 into my other partial derivative, okay, 2 minus 4, well, that's negative 2, 2 here. So my y, I'd have to look at what would y have to be to equal 0. Well, y minus 1, that would be 1 minus 1. So y would have to be 1 for this 2. And there's only one y over here, so there's only 1, 2, that's my 2. And then the 1 comes from that y here, making that 0. So I have 3 so far. And now let me look at this y equals 2. Well, that gives me 0. Let me go over here. If I put 2 in here, that's 2 minus 1, that's 1. So again, I'm looking at two different x values that would make that 0. So my y is 2, but I'm going to have two different x values, 0 and then 4. So I'm looking at 5 different critical points. Now you might be like, well, what about these over here? Well, we could actually go through what we just did with our partial derivative with respect to x. We could do it with respect to y, but we're going to get the exact same critical points that we got for this partial derivative. It will be the same. I'll go ahead and go through it just so you believe me. So we're going to check these values, but again, we're going to come up with the same ones. We're just going to end up doing it twice. You don't have to, but so when x is 0 here, I get 0. Plug my x in here, and I have two different y's that I would have to look at. So that tells me I'm going to have 2 of them here. So when I put 0 in here, okay, sorry, for my when x is 0, okay, I don't get 0, but when y is 0, that would be one of them. And then when y is 2, that would give me my other critical point for that, or critical value, or the point that would go with that value there. All right, let's do 4. Again, 4 here gives me 0, so I put 4 into the other partial derivative. 4 minus 2 is 2. Well, what y value, and actually there's 2 of them here, 2 y values again. So I'm going to have another 4. So 4 here. So that would mean y, if I have 4 here, y could be 2 or 0. Again, that would give me 0, or a 2 there would give me 0. And then we'll check the 1. Again, 1 here is 0. So if I put 1 in over here, 1 minus 2 is negative 1. So what x values, well, there's only one x value that we have to worry about this time, and that's 2, 1. But as you can see, these are the exact same ones that we got over here as far as finding the critical values.